pretty short. Slopes of lines. I'm going to go a little over 10 minutes on this one because this is like a double lesson. Slopes can be thought of in many different forms. Slope is usually represented by the letter M from when France was really big into math. The French word for mountain, I think, is mons. And you think of the slopes of mountains. It's basically the rise over the run, the change in Y over the change in X. That can also be used with Greek letters, delta Y over delta X, that delta meaning change in. And so finally we get our formula Y2 minus Y1 over X2 minus X1. So sometimes when people are finding slopes, they might just want to plot the points 1, 2, and 3, 4, or 3, 3, let's say. And they actually look on the graph and they say, hey, look at that, rise over the run. I'm going over 2, I'm going up 1, so the slope is a half. That's fine. I mean, if you insist on using the formula, fine. Use the formula. 3 minus 2 over 3 minus 1 is 1 half. Okay. Now, how can you find slope from the equation of the line? Well, we're going to talk a lot more about the different forms tomorrow. A lot of the forms you're familiar with, y equals mx plus b, right? Y equals 2x plus 9, so the slope is 2. But what if you don't have it in y equals mx plus b? Do you have to put in y equals mx plus b to get the slope? If it's in standard form, ax plus by equals c, well, yes, we could squeeze this into slope form, by equals negative ax plus c, divide through by b, negative a over b x plus c over b. So you could memorize that the slope is negative a over b when you're in standard form. That's not such a bad idea. Sometimes you have to do a mix of memory and process in mathematics to come up with your most efficient methods here. And another good reason to memorize this formula is that you start understanding that the coefficients on x and y in this linear form that are actually creating the slope. And that will come in handy in some other work later on. Now, parallel lines, geometry versus algebra. We looked at this already. We said parallel lines look like that. They never cross in geometry. In algebra, it's the concept that the slopes are equal. Slope 1 equals slope 2. So remember what I was saying before? When you look at things like 5x plus 2y equals 6, that's going to be parallel to 5x plus 2y equals 7. Because basically, it's the a and b, 5 and the 2 here, and the 5 and the 2 here, that are determining what the slope is. So if you keep the same a and b, you're going to have the same slope. They're different lines because I put a different constant here. Finally, perpendicular lines, geometry versus algebra. In geometry, it's kind of hard to get a perfect perpendicular line, but let's give it a try there. Oh, yeah, look at that. That's pretty nice. In geometry, you have that special mark you put on them. House on the corner there. Determine the right angle there between the two lines, making them perpendicular. Algebra? Any ideas? Perpendicular lines in algebra. You got your two slopes. They're not here. Clearly, these two slopes aren't equal. This is a positive slope and this is a negative slope on these two lines over here. And it's not just they're just opposites. If we just look at opposite slopes, like slope of 2 and a slope of negative 2, that's over 1 up 2, over 1 down 2. Those are not perpendicular. So it's got to be negative reciprocal slopes. Negative reciprocal slopes. So slope 1 times slope 2 equals negative 1. or the perpendicular slope is -1 over the original slope. That's that negative reciprocal idea. You're reciprocating and you're negatizing it. Okay, well that's it. We'll do more examples in class, and I went a little over, 16 minutes, but this was a double lesson. All right, see you in class. Flange out.